this afternoon, it's a two-in-one discussion on technology and innovation. The first one would be on conventional energy, issues of conventional energy, innovation, and the future outlook for conventional energy. And the other session is on the same aspect of renewable technology. We have two eminent keynote speakers. They are for the first, on conventional technology, we have Mr. Vishal Vanchu. He is the senior official of, and another is Dr. Saidul Islam on renewable energy. He's come all the way from Australia and will be leaving after the seminar. We have panel discussions after that. Following the two panel discussions, we'll open the floor for Q&A, and then we'll have a final closing remarks. I'm told you need some break, so I'm sure the announcer would announce some break between the full session. So shall we start off with the first panelist of today's seminar, and may I invite Mr. Vishal Vanchu to make his presentation.
Honorable Advisor Dr. Chowdhury, other distinguished guests, ladies and gentlemen, good afternoon. It's a real pleasure and an honor to speak with you this afternoon on this exciting topic of new technologies in really one of the most critical sectors that's the foundation of GDP growth in many of our emerging markets in the power and energy sector. So if you look at the rate of change in technology, it's probably the fastest it's ever been in our time and age. But what's interesting is that some of the recent predictions are that this rate of technological evolution is probably the slowest that we'll ever see ever again. And that's an interesting prediction because that tells us that the rate of change of technology is going to be even faster than what it has been in the last few years. And especially, I would say, related to the digital and technologies, the rate of change is going to be rapidly evolving, and it's going to be integrated into everything that we do in the power sector. Results? So while he's pulling up the presentation, I just want to start with some of the macro dynamics that are happening globally in the power sector. And I would summarize these into three fundamental directions. One is decentralization. So we're seeing more decentralization of power generation systems, smaller, more distributed power systems with microgrids. The second trend that we're seeing is on decarbonization. Many countries have made the commitment to reduce their carbon footprint, and this is resulting in massive implementations of renewable technology driven by solar and wind technology. And thirdly, digitization. So these are the three main global trends, macro trends, and digitization is one that will probably see the fastest and most rapid evolution of technology. We have huge amounts of computing power, which is now miniaturized. We have machine learning and artificial intelligence technologies that are matured, and this will enable huge amounts of productivity in power generation systems and everything that we do in the energy sector. So these macro trends, while they may be accelerating in some parts of the world, but we'll see this evolution pretty much happen across every country over time. So that's the first, I would say, summary of macro trends around the world. Just touching upon renewable technology, which is probably one of the most significant trends that we've seen in the power sector. If you look at the forecast for 2018, we're going to see 200 gigawatts of orders generated for renewable technology. 120 gigawatts of solar, 80 gigawatts of wind. This is going to be more than 2/3 of the power addition orders across the world. So we're seeing huge strides in the installation of solar and wind, which really causes its own challenge. We know that solar and wind doesn't provide round-the-clock power. It's an intermittent source of power. So sun doesn't shine during the entire day. And this is driving huge investments in battery and storage technology. So we will see more and more evolution in battery storage systems. And this is not just battery technology, but control systems and how we can control the dispatch of power and the storage of power at the right points in time. So we'll see more hybrid systems with combinations of solar and storage, with combinations of wind, solar, and storage. So now that we have the slides, and so we will see cost points in storage systems which will continue to decline. And this will provide the ability for us to provide round-the-clock renewable power over the next few years. And this is technology that will be delivered in many parts of the world. It's fine. Next is microgrids. I talked about this. We're starting to see pilots where there's microgrids in communities, especially with rooftop solar. We actually have consumers now that not only consume electricity, but they're also selling electricity. And microgrids is going to be an important technology as we evolve. And finally, if you look at transportation sector, the advent of EVs and the adoption of electrical vehicles in all of the mobility in cities and towns is going to drive further demand for electricity. This will be somewhat offset by a lot of the energy efficiency initiatives taken on by the countries. But we will still continue to see clearly an uptick in demand. Having said that, talking about the macro trends that I just talked about, in the end, energy needs and power needs are very local. They're very dependent on the local dynamics in the country, and so it's not a one-size-fits-all. I'm not going to read through the supply and demand factors. You can see them, but clearly some of the most interesting supply factors are going to be the availability of fuel, such as coal and gas in the countries that we're talking about, the regulations. On the demand side, we're going to see, of course, especially in the region that we live in, an uptick in demand because of the rising middle class, the consumption patterns of electricity, with a lot of new consumers coming into the market that are going to be consuming electricity. Having talked about some of the global trends, I just want to spend a second talking about South Asia. And I'm talking about really the main countries of Bangladesh, India, and Sri Lanka. I would say there's an intersection and a convergence on the strategy and the importance of what we see in the South Asia market, which is the focus of the governments to provide reliable access to power, cleaner power, and affordable power to all citizens of the country. As all we know, there's a lot of citizens in our countries, in the three countries that I mentioned, that don't have access to power. And this is something that is a priority for governments. But it's not just the citizens of the country, it's also the industry. You look at the textile industry in Bangladesh, it is dependent on access to reliable power. It's a big portion of the GDP of the economy and a big portion of the GDP growth that's important for countries. So if you look at the market landscape in the three countries that I talked about, there's certain common characteristics. There's some differences, of course, but if you look at GDP growth rates, all in the 5+% range, Bangladesh has been a stable economy, driving 5+% GDP growth rates for a number of years. They have ambitious plans to add 30 gigawatts through 2024. This is important to sustain the GDP growth. In India, which is now a major economy, there's a massive investment in renewables, which you'll hear about in the panel discussion. Huge improvements in renewable technology, ambitious plans in India to add 200 plus gigawatts of renewable power by 2022, and even in Sri Lanka, we see the need to continue to add power. On the right-hand side, what you see is the per capita consumption, and I think this is no surprise. In these three countries, we are well below the average, even in countries like China. We compare ourselves to China on per capita consumption, and we know this will go up. Given the rising middle class, given the urbanization, this is going to rise, and this will drive further demand in electricity. We do face some challenges in this part of the world. Some of the challenges in the power generation side is, of course, availability of land, land acquisition, availability of local fuel, coal and gas. But there are technologies in place that make it available now to bring it in, to import these technologies, import the fuel. On transmission and distribution, we have a lot of work to do, but there's good progress. So if you look at Bangladesh power generation market, some of the market drivers that we see, there has been availability of domestic gas, but that's not enough. That is driving some of the strategies for investments in Bangladesh from a power generation standpoint. So clearly LNG is going to become a very important element in power generation in the country. Coal as well, as you can see from the power generation mix in the middle column. And certainly gas to power infrastructure, which is now becoming available from companies providing the full ecosystem, is going to enable really gas power over the next few years in Bangladesh. This diversity of fuel mix that you see, I think is an important element for any country because it does essentially provide some sort of insurance and energy security for countries to be able to diversify their power generation mix. If you look at the grid system in Bangladesh, it's evolving. There's high voltage DC, which is the transmission for bulk power, which is evolving in the country. Additional 30 gigawatts is going to require these technologies. And there's a big amount of investment that's going to be needed in these systems. So I just want to switch to really the main kind of core of the discussion, having talked about some of the dynamics, which is what are the innovations that are taking place in a lot of these technologies, and how is it going to impact some of the strategies for countries in the region that we live in. I just want to say that there's a huge amount of investment in all technologies, in all forms of power generation technologies that is being done by the global companies such as ourselves, whether it's gas turbines, steam turbines, boiler technology, wind turbines, solar, etc. But we do believe that local partnerships are very important. Local innovation, whether it's innovation in business models, there's a lot for us to learn from local companies, and these partnerships will continue to be extremely important. And we've seen good results from some of these partnerships that have enabled power generation acceleration in countries like Bangladesh. So I want to just quickly touch upon some of the key elements of innovation that are occurring in the different forms of power generation. First and foremost, I want to talk about steam and coal-based power generation. This will be a technology that will stay in place and provide power generation, baseload power generation, for many countries in the world for years to come. So coal-based power generation is not going away. As you've seen from the mix in Bangladesh, it will be part of the power generation mix. India, about 70% of the power is coal-based power generation, so it's a very important element. We've seen an evolution, a technology evolution in coal-based power generation. We are investing heavily in advanced materials, in 3D aerodynamics design that is enabling the movement of steam turbine technology to be able to provide what we call advanced ultra-supercritical operation. This enables better efficiency. We're able to operate at, as you see here, at 1.6% better efficiency than the OECD standards that are set and the guidelines that are set for ultra-supercritical operation. This provides 2% better levelized cost of electricity. It provides a 80 million net present value benefit over the standards that are set if you look at the life cycle of a plant. And we are now investing and have available what we call SteamH technology, which provides another improvement of 1.6%. So this can provide 160 million benefit over the net present value over the life cycle of a coal plant. So good emissions, we're 3% lower in emissions versus the standards that are set. So coal-based power technology is evolving. There's lots of investments going in. If you look specifically for countries like Bangladesh and other countries that have lack of availability of land in order to invest in larger coal plants, which take longer to implement. Typical life cycle or implementation cycle is 5 years. We now have technology available in the 300 megawatt range, which requires a lot less land usage with the same capability as advanced ultra supercritical technology. So we can operate at about 2 to 3% higher in efficiency than the world standards. Again, better emissions, faster implementation times. These plants can be implemented in 3 years, so faster time to electricity generation on the ground. So switching to gas turbines. Again, big investments in gas turbines in improving efficiency, incredibly important in markets like Bangladesh. You can see every 1 point of efficiency gain is a $30 million US benefit. If you look at technology that's been available conventionally over the last few years versus the technology that's available today, which is H-class technology, which is about 3% higher in efficiency, with today's LNG pricing, which is really going to be the predominant source of fuel in countries like Bangladesh, we're talking about $100 million of benefit over the life cycle of a combined cycle gas turbine plant. This is huge investments in material technology, huge investments in cooling technology. We're operating at much higher temperatures in these types of product ranges. So integrated gas to power. This is, I think, a good example of how partnerships and local innovation can make a difference. You know, companies such as ourselves and other companies have started to invest in really providing an ecosystem of full LNG import, availability of LNG in the country to providing a gas power plant, including ability and availability to financing, project management. This is what's enabling and will enable huge power additions over the next few years in Bangladesh. So big progress in gas to power in the H-class technology that I talked about. And finally, of course, renewables technology, which will play a big role in many countries around the world, is playing a big role in many countries around the world. We see big advances in wind turbine technology, both in onshore wind and offshore wind, larger rotor sizes, larger megawatt ratings, higher towers, where ability to capture power at much lower wind speeds, which is essentially what you're going to see in many countries where the attractive land which had higher wind speeds has already been utilized. So this investment in wind technology is very important. Offshore wind, which will become a technological, I would say, necessity and will be implemented in many countries around the world, is around the corner. So big investments also in offshore wind technology. These are massive machines, 10 megawatt plus machines, and we have the capability now to install them and generate electricity from offshore wind. And of course, solar technology. Big innovations in solar inverter technology. I already talked about battery and storage technology, the ability to integrate battery storage subsystems with solar to provide round-the-clock power from renewable sources of power. In transmission and distribution, lots of advances in control systems. Control systems are very important in implementation of HVDC technology. These are much more modular, compact, programmable control systems, which improves the speed of implementation of these high voltage DC systems. So big investments in that technology. And then finally, substation technology, which really hasn't, I would say, evolved over the last 10 years. We're making big investments in digital substation technology. I talked about digital technology in general. It's finding its way into technologies such as this. So we're able to use fiber optics instead of copper. Again, it improves cycle time of installation, the ability to manage these substations remotely, improve reliability of these substations. This is going to be critically important for essentially evolving transmission and distribution infrastructure in this country. And finally, I want to talk about digital, because this is probably pervasive through every technology that we're talking about. We have huge, as I said, improvements in computing power. We have massive improvements in sensor technology. These are cost-effective technologies where we can control, or we can connect pretty much every asset in a power plant, whether it's a renewable plant, gas turbines, steam turbine boilers, et cetera. We can monitor and get real-time data from these plants or these assets. We can manage unstructured big data with newer technologies that are available. And we can provide real-time feedback to operators on asset health, the predictive maintenance capability where we can inform operators on whether a part is going to fail so that these parts are managed and replaced before they actually fail and bring down a power plant, which is obviously very costly to a developer and operator of a plant. So big, I would say, impact with what we're going to do in digital. Just imagine a scenario which is not science fiction anymore, where we can monitor an asset, provide an automated alert to a field service engineer on an issue. We can have a drone sent out to inspect the asset, and we can have an automated response to a service field engineer to essentially target the part that is needed. And instead of having spare parts on site or bringing the wrong parts, you know exactly what part needs to be replaced, and those parts are sent on site by the field service engineer. All this is reality. It's actually happening today. Yes, it's not pervasive, but this is something that we will see in the next few years. So this ability to monitor, diagnose, optimize performance, and when I say optimize performance, you're optimizing efficiency of power plants, optimizing the dispatch of power, especially important when we're talking about renewable power, and when to store, when to dispatch, which power plant asset to use. So this is, I would say, round the corner, and this will probably have, I would say, the biggest financial impact. And we're talking about, and this is on a global basis, we're talking about probably $1 trillion types of impact in terms of productivity and benefits. So I know this was a quick fly-through on some of the technology innovations around different parts of the power generation and distribution. I want to just summarize my talk by saying lots of change that we're seeing in the energy ecosystem. Yes, there are some challenges, but there are huge opportunities with these changes. Significant advancements in every type of power generation technology. So it's not just one technology that's evolving. Big advancements in digital, which will have a huge impact, and I would say the productivity or efficiency of power plants, but also the productivity of field service engineers and people that manage the power plants. You know, Bangladesh is a strong power market. We've been investing in this market for many years. We're fully committed to continue our investments. They're ambitious plans, but the achievable plans of 30 gigawatts of additions, which are absolutely achievable. It's a stable PPA regime, which attracts companies such as ourselves. It attracts financing multilateral institutions, so financing is available for these projects. And there's a strong commitment from the government, and as, of course, certainly from Dr. Chowdhury and his team. So with that, I just want to thank you for your attention, and I'll turn it back over to Dr. Chowdhury. Thank you.
Thank you. Thank you, Mr. Mr. Vanchu brings in a lot of technological experience and, you know, management and implementation, being president of GE in South Asia. Thank you very much for your very illuminating presentation. May I now request Professor Saidul Islam, who is a professor of Curtin University in Australia, and kindly agreed to make presentation on renewable energy. You know, the first speaker always gets a preference. He gets his time. But as the speakers we run down, we squeeze in the time. So you got 15 minutes. Thank you.
Thank you, Mr. Chair, Honorable Dr. Taufeeq Elhaj Chowdhury, distinguished panelists, fellow panelists, and distinguished guests, ladies and gentlemen. And it's an exciting time for Bangladesh. We've been hearing for the last 2 days that we have an enormous challenge of fueling the need for the country's development, which is unprecedented. We are predicting a growth of around 8.2%, which is unheard of in the developed world, at least where I live in Australia. They will be pleased to have a 2% growth if they can. So this is an exciting time, but growth comes with challenges. And our challenge is to find the solution to the additional 30 gigawatt or so in the next decade or so. It's a big challenge, and this cannot be alone filled by just keeping on additional generating units. It has to find intelligent solutions. It has to be a concerted effort and a various model of finding efficiency, energy conservation, demand management, renewable technology, energy mix, fuel mix that need to be found to find ourselves in a situation where we could tell the world and our future generation that, well, our energy future is in good hand, and hopefully they will thank us for this. So I thank Bangladesh Power Development Board for arranging this seminar series and inviting me to give my speech. As Mr. Chair said, that I will have 15 minutes, so I'll try to cut down on my talk. And, but I think that you have a copy of my slides, so I think you wouldn't miss much on that. Okay, so what is the... I just would like to change these slides. So slide change is here on the... Okay, okay, thanks. Okay, so basically we know our grid as we see on the left, right? Generation, transmission, distribution, right? But things are changing. The grid we know is changing, and it is now basically the energy wave. It has got different kind of technology, cogeneration, distributed generation, energy efficiency measures, control, communication, battery storage. Everything is being now coming onto the grid. So what we are changing into is a smart power network solution. The transition to smart power or smart network is essentially transforming consumer into prosumers. So consumers are now also producing energy. So there's a new term, prosumer. We are seeing centralized energy supply into distributed generation, basic infrastructure turning into smart networks. We're seeing now centralized operation to distributed operation. We are seeing expand network to follow the load growth to utilities existing network efficiently to manage loads. And monopoly grid is being transformed into microgrid and nanogrid. So we're having huge transformational change. Well, what that basically is doing, I mentioned prosumers. If you look into this slide and see the smart home picture, you will find out that a home now no longer is a humble home that just relies on the distribution from the distribution transformer. It actually is generating rooftop PV. It has got its own battery storage system, Tesla Powerwall, if you may like. It has got control comms that communicates through the local area network to the wide area network. So it is basically a wave of energy solution now. So I just would like to, in my talk, my previous speaker and over the 2 days that a lot of people have talked about renewables and other solutions for energy. What I'm going to do is show you some experience that we had in Australia, okay, in terms of intelligent energy management and how they are finding the solution to their energy need. If you look into this, this is a typical distribution transformer. And if you see, all those distribution feeder were fed through a smart meter. Well, what this is basically doing is, it is targeted toward developing a dynamic tariff. So the tariff structure which the customer responds to is no longer static or is no longer in steps. You could have dynamic tariff and you can set the time, minute, 5 minutes, 10 minutes, whatever you like, okay? And this figure is basically telling you that how that can be done. So you could look into the load curve on the left And then on the right, you could design a tariff structure, okay, that is going to encourage or discourage customer through price signals, through smart meters in their home, through their home area network, through their intelligent appliances they use, things like their refrigerator, things like their washing machine. They could be all using Zigbee technology, okay, to basically communicate with the smart meter and respond to the need. The customer himself might be anywhere, working in a shopping center, but he might have an iPhone app that he could also intervene and interrupt at any time he or she likes. So this technology is changing the behavior of human being. Energy storage is a big part of today's renewable penetration. We all know renewable. We have heard about renewables. I'm not going there. But what it is, whether it is wind, whether it is solar, it's all stochastic variable. What you need to smooth that out, and you could do that by energy storage technology. In this figure, you could see the various storage options, the prices, the cost of energy storage, and also the per cycling cost of energy. You could see that lithium-ion, lead-acid, the battery leads the way, and then when you go to things like pumped energy hydro storage, you get the most cycling favorable cost, okay? And the size of those energy storage devices also vary, depending on whether 1 kilowatt hour, megawatt hour, or gigawatt hour, okay? I'm showing you some picture here that is changing the behavior of commercial and residential customers in Australia. Look at this figure. That basically is a warehouse. And the warehouse had 1,500 and almost 50 meters square of roof space. What they have done is they have talked to the utility and they have negotiated an arrangement by converting their entire roof space with solar. And now, in this way, they have committed to a dispatchable power to the utility so that when utility needs, they are actually committed to supply that to the utility, okay? But at other times, they can use it for themselves. And in this way, they save almost 60% of the cost of their electricity. So it is gearing toward affordable electricity. What storage can do in the utility scale, this figure is showing you that. On the left, you see without storage. Basically, you have got solar PV generation during the midday. And then on the right, you see there is about 2 hours worth of load peak. Well, one option for you would be to go and put in peaking generation. I don't think it's the wisest solution. What this utility has done is look at that. What they have done is they have taken some excess energy during the midday, converted into storage, and then they have shaped the peak, which is shown in the right-hand side figure, and that is doing exactly the same thing as adding peak generation. Okay? So generation can be met through some storage as well. This is a community microgrid solution. So it is example from a residential development. What that development city has done in terms of writing their covenants is that every landowner have to put in houses where they must have rooftop PV of certain size. But instead of having individual battery energy storage, the community put together a community energy storage. The utility signed up and supplied with backup power if necessary for reliability, but instead signed a dispatchable arrangement with them whereby they could actually draw from that during the time of need. So this is a win-win situation for both. And they don't, the residences basically are not relying on feed-in tariff or sending it to the grid. They're putting it in the battery and using at night as well, outside of the peak hours. Virtual power plant is another technique that is giving people an opportunity to have alternative to power generation, okay? So this is an example from the European project on a smart grid, and you see that how various energy sources, including small-scale rooftop PV, including pumped hydro storage, including wind, solar, battery, they are integrated through an energy web and an Internet of Things web so that they could have a virtual power plant. And that is all solution to having energy. I'm going to show you another example that I was involved in my local utility, and this is again a residential feeder, and we know that there are technical challenges of renewable penetration. How much renewable is actually allowed in our grid, in our distribution system? So this is a study to test that. What I'm going to show you here on the left is the rooftop PV generation that you can see, and on the right you can see that houses that has got rooftop PV and that do not have, how the after demand diversity demand of that house is changing. And you could see that there are significant changes in the house that has rooftop and house that do not have rooftop. One thing, however, is clear from that study that I could show you is it is this figure on the top left, that the peak demand, however, is not changing, as because that just like Bangladesh and Australia, we have our peak demand around 7 p.m. and unfortunately by 6:30 the solar is down. So therefore peak demand is not affected by rooftop PV, but look at in the middle what is happening. Basically there are a period of time when the infrastructure, the distributed energy infrastructure is totally relaxing. Imagine a distribution transformer that is sending no power through, okay? And this is an enormous change to the asset management. Therefore, we need to have judicial thinking in terms of how we plan and how we design our upstream assets, okay? And there's a lot of savings, a lot of money could be saved. Electricity industry is very cost intensive, so a lot of things can be achieved there. The other thing that you see in the figures, that those myths that if I have more renewables, I'll be violating network constraints, grid codes, are not true. Because this study, which is actually a real study, it is showing that the voltages on the network could be perfectly managed with appropriate reactive compensation. We all know that electric vehicles are coming. We can't stop it. These are examples of them. These are real electric vehicles available in the market. So G2V and V2G is an option. And it is going to hit us whether we like it or not, okay? And we got to be preparing for that. As a matter of fact, it's an opportunity when the vehicles come into the market. Just a simple Nissan Leaf car has a 24 kilowatt hour worth of battery. The statistics show when a car comes to home, it has got still 60% of the battery left. That means that a Nissan Leaf could actually generate 25 kilowatt worth of power for an hour, okay, with the excess electricity. Okay, and this figure shows, okay, thank you. This figure shows that how by using the G2V, the load curve could be changed. So we could actually have night charging after the peak demand has gone through, and then still we could valley fill, as we see on the left, as off-peak energy for electric vehicles when they come. There are a lot of new technologies coming into the grid, such as the PMU, the Phasor Measurement Unit. They can measure the status of the network second to second or millisecond basis. You could, rather than installing new infrastructure, new transmission line and etc., you could do dynamic loading of the transmission system and use the same line to pump in more energy as the environmental criteria suggests, like temperature, wind speed, and so on. I think interesting thing in the developed world, the energy use is changing. Actually, it's reducing. It's not that they are using less energy, but more of them are being used or developed by themselves. And the utilities picture is what you see here. Okay, what we are seeing here is that the electricity consumption, okay, in Bangladesh and India. See, there is an astronomical change in the electricity consumption. Of course, we are starting from a low base, so there is no doubt that is happening. But this needs to be found by renewables. While we see that Australia, UK, those sort of countries are still generating and generating now 15% renewable, in Bangladesh that is not happening, or in India that is not happening. I think in developing countries that's not happening, and it has to happen. Otherwise, we won't be able to fuel this demand, and it will not be wise to chase those peak generation. Of course, subsidy cannot continue. We all know, okay? And therefore, we need solutions that is affordable and reliable and grid-wise solution. What I'm going to tell you basically is this figure, if you see, the Electricity Network Association of Australia basically predicting that by 2050, they will bring down the energy cost of a household by $400. And they want to do that by having found reliable and efficient network, as well as network assets and efficiency in generation. I think in terms of Bangladesh, we need to find a lot of, policy around that. And I don't have time to go through this with you now, but I think we are here. We have heard a lot of panelists over the last 2 days, and you will hear today, and you have got my notes. You could see that some of the things that can be done in Bangladesh in order, basically, to have an efficient energy mix. Bangladesh could go to offshore wind energy technology, okay? I know that we don't have too much wind onshore, but offshore wind we can have, okay? 100 kilometers from the shore you can go and you can find good wind. And you can have up to 6 megawatt of one wind turbine. You can build gigawatt worth of offshore wind. In the world today, there is over 1,500 gigawatt worth of offshore wind. So essentially is a feasible technology. This is my last slide, Mr. Chair. And what you see here is that if you see the two last things, which way the IEA, which International Energy Agency, is predicting the generation mix, okay? If you see on the right-hand side, they are actually revising their prediction about coal, that's going negative, and they're revising their prediction about the natural gas. This is to be filled in through nuclear, wind, solar, and other forms of renewable energy. So essentially, I think that we need to consider this trend, that which way the world is moving, and we should keep that in our short, medium, and long-term energy plan. With that, I finish my talk. Ladies and gentlemen, thank you very much for listening.
Thank you very much. I see a very big report that you have prepared for this session. So thank you very much. I hope the organizers will distribute this report. It's a very valuable report has been distributed. So thank you very much. Sorry that we cannot give you more time. Let's now move to the panelists. May I first request Mr. Jia Zhuzi, CTO Power and Gas of Siemens, to make his intervention. We have 5 minutes for each one of you because panelists have taken more time.
All right, it's a great honor to see a full house here. That at least tells me one message. That means we have a similar number of the dear colleagues are interested in technology compared to this morning, right? Interested in the money. Great honor for me to be here. Such a promising, growing economy, which requires a lot of power. And from my side, actually, I have a few points I would like really to share with you. As Vishal mentioned, there are some mega trends, and people all see. In the future, carbon will go out of system, and the whole energy system is getting much more complicated from generation, transmission, distribution, and utilization perspective. Right? And for that, we have to go through the transformation in a step approach. But I want to put my 5 minutes, right now 4 minutes, into a perspective. That means there is priority, there is sequence in terms of the power and energy. First one is availability. Do you have access to electricity? To generate electricity, do you have access to coal, gas, oil, and renewables? Right? That's number one. Number two, assuming you have the availability from your fuel to your power generation units, can you afford it? Why everybody in this planet know coal is dirty, but in the Southeast Asia, this region, still coal is a viable option because finally, optimum solution for this region, well, at bridging, they have to look for coal because it's cheaper, as simple as that. Number three, somehow it's in contradicting. Is it sustainable? That means if we look out for next 10, 20 years, the investments you are going to make, be it nuclear, be it combined cycle, be it coal power plants, right? Can you have your investment back in a more healthy and safe way? So basically, you do not want to end it up with the stranded assets, as we discussed this morning. But finally, nobody wants blackouts. That means you need a lot more protection in the coming, let's say, trends. So in summary, I think this morning, one key word I took away is the efficiency. And over there, I want to just spend the other 2 minutes. And there are different levels about efficiency, right? The first level, as simple as you want to have more output from your limited inputs. Input can be coal, can be your LNG, can be the sunshine or the wind. But how would you get more out of it? There's no magic here. You have to go for the physics, very fundamental physics. That means, can you handle the high temperature for combined cycle, right? The gas turbine. And can you deliver more efficiency? And I guess together with my friend from GE, we have the most, let's say, efficient gas turbines in the whole world. That's one level. The second level would be more challenging, but it has been realized as of today. That means without touching your hardware, all right? For every component, every equipment, your power plant or your facility, you do not touch any bit of your hardware, but still you are getting more out of it by digitalization. I mean, digitalization is such a broader term. Big data, analytics, artificial intelligence, Internet of Things, cloud, we can go on. But fundamentally, it does four things. The first thing actually, like our body, we have body temperature, we have our heartbeats, right? Pulse check. Do you have good data? You can have more, let's say, insights into what's going on, what's the current status quo of my equipment, my power demands, my home mix, right? People are traveling, you have the festivals, and there's the monsoon season, there's still politics. Can you somehow model it? Then you know what's going on better than anybody else. The second, we all get diseases as human beings. Can digitalization help you to diagnose your, let's say, root cause, right, through the symptoms? Number three would be, all right, I know what happened over the past. You have history of the heart disease or skin, let's say, disease. But what about in the near future, right? In the weeks, months, years? Can you predict, which is very, very difficult, but I haven't gone to the number four, which is more difficult than number three, assuming you can predict a lot, but what to do about it? Prescription from doctors. If you have all of that, by the way, we have demonstrated that, you can get a lot of efficiency out of your existing assets. And by the way, everybody knows the Paris Accord, right? 2 degrees versus 3.5 and 4 degrees. The study from the IEA, International Energy Agency, without really increase any volume of renewables, of course we do that. I come to that the second step. Just by putting money on energy efficiency, we can sustain this 2 degree scenario, all right? Of course, we should add more renewable, then we can go back to ground zero, which means we are not emitting more CO2. So I would say, put into the perspectives, hardware, right? There's physics, which there's great players we are leading, digitalization. Without touching the hardware, you are increasing efficiency. The final point, I really want to make this, we should not blind ourselves only looking into the power generation, especially from government perspective, because worldwide, the CO2 emission, especially Bangladesh as a nation, we are subject to the climate change, right, the sea level. And only 40% of the CO2 are coming from the power industry. The remaining 60%, right, is coming from transportation, coming from the building, coming from industry processes, as well as agriculture, you name a few. And how do we have a holistic solution, which means the total energy management, right? From oil and gas, from power, from infrastructure, from industry processes, where you go for the system level efficiency. And we do have the great tools to help you to model and to go for the holistic efficiency. So that's a few cents from my side. I hope I do not take too much time. Sorry.
Thank you. Thank you very much. Thank you. May I now invite Vishal Mehta, partner and managing director of BCG, to make his intervention.
Good evening, everyone. As I was hearing the presentations earlier, I'm facing a dilemma in terms of the topic when we're talking about innovation here. Sitting at the place where we are, in this part of the world, we have a very unique situation where we are trying to provide access to energy to a large number of people, and at the same time trying to ride the global trends around renewables, new technologies, climate change, etc. So there is a very unique challenge, where you have to do both of them at the same time. Most of the developed markets or the Western markets are trying to reach their climate change goals by a fuel transition, right? Whereas, because they do not have the energy access problem. Whereas what we are trying to achieve here is, how do I ensure that I provide energy to everyone, which means my conventional sources like gas, coal, etc., continue to be there as part of my energy mix. If I look at some of the numbers that are being projected for Bangladesh or, where I come from, India, it's not just, holding steam, but also kind of increasing in terms of numbers, right? So the dilemma is that you have the innovation dollars which are moving towards renewables, storage. Who's going to continue the pace of innovation on the conventional side, right? And which is where I just, taking off from the point that Vishal, you mentioned was, a lot of that innovation will have to come locally, which means, it will have to shift from where it was traditionally done, maybe the US, Germany, to this part of the world, which means you need to invest in R&D in terms of talent in this part of the world, so that, while a lot of the innovation is being focused on the renewable side, there is enough happening to increase the efficiency, as well as, ensuring that those technologies are also getting cleaner to the extent possible, right? So, it can't be like fossil fuel will not be clean, but, as clean as you can get within the realms of science. So that's one dilemma. The other is, and this is slightly projecting forward, if you think about, today's youth or people who are kind of getting into technical education, right? They would be less and less attracted by the traditional or conventional education, which is, we used to be all proud to say that we are electrical engineers or thermodynamics or mechanical, right? Most of the youngsters would now want to get into the electronic side of the technology. So as we grow our asset bases, the key question is, how do we ensure that the dependence on talent reduces for at least the conventional part of the business, which is where the key trend of digital comes in. The sensors are getting cheaper. Intelligence is moving from engineering to mathematics. How do I use digital as a trend? How do I use digital as an innovation, analytics, so that I can invest in specialized less number of people, but still ensure that I get the maximum efficiency from that. So that's, I would say, sitting where we are, that's the other challenge we have, that while we would have in terms of quantity the number of people, but it's going to get increasingly more and more difficult to attract people to the conventional sources. So we really need to invest in the digital side of things, the business process side of things, and the innovation needs to be centered over there, so that you continuously keep upgrading even your conventional sources. So those are my two additions to what was earlier said. One is, how do we look at innovation in the conventional sources and not let it get crowded out? And the second point being, how do we use digital to ensure that we reduce the dependence on talent and people, and kind of keep upgrading ourselves.
Thank you very much for making very precise intervention, Mr. Mehta. May I now invite Professor Dr. Zahoor Haq of Bangladesh Engineering University and Technology to make his intervention.
Assalamu alaikum, Honorable Chair and ladies and gentlemen. It's a privilege to be here to share my some thoughts regarding the energy efficiency and power generation. We are developing fast. That has certain problem because we have to produce a lot of power. We have to generate a lot of power. And if we can't supply power, then all our achievement will be nullified. Yeah, so we have to produce a lot of power. So our target is to go for renewables. Initial target is around 10%, then maybe 50%, but 90% and a greater fraction has to come from hydrocarbon-based fuels, that is from the conventional sources. And so we have to plan, and the planning has certain problem. As for example, I was involved with the ISO standard, carbon footprint. World is now concerned with the global warming and the carbon dioxide generation and that sort of things. So if the carbon footprint standard is adopted by the world, then what will happen? You have to mention the carbon footprint number for a product, so that if you go for a higher carbon-based fuel, then your product will have a higher number and it creates a problem. So if even the coal becomes zero price, then actually we have to go for a higher less carbon-based fuel. So if we go for a coal-based power plant, we have to go for high-efficiency coal-based power plant, because we have space limitations. As you know, if you want to build a coal-based power plants, it has to be in the coastal area, because you have to transport a lot of distances. So maybe rather than going for a very basic coal-based power plant, we have to go for IGCC, because it will have a higher thermal efficiency. So it's the planning, because if you want to meet the power in next 20 years, in next 40 years, you have to plan now. So I want to also stress some other sources. As for example, in Bangladesh, we waste a lot of energy. I have the privilege, I have the chance to visit a lot of industries. I have seen a lot of industries just using gas generator, exhausting a lot of heat. Next to the gas generator, there is a boiler. They are burning the methane, and also they are using a lot of electricity to get the electric for the cooling. But if we go for integrated energy optimization, that is, I have heat, I shall use the exhaust gas for either maybe for heating or maybe for the cooling. So we need a optimized solution. So only the energy efficiency of a particular process may not be the ultimate solution. Rather, we need optimized generation and also optimized solution. As for example, I can give you another example. We waste a lot of energy. I had the chance to work with the ISO, then I had the chance to visit one of the units in Stockholm, where they collect all the sewage from the Stockholm city, they process it, they produce biogas, they separate the carbon dioxide, they produce CNG, and they use that CNG in their bus service. The technology is not that difficult, but you have to adopt it. So you can just go to Stockholm, get the things, look at the things, you just copy it. It will not work here. So we need a lot of innovations so that we can adopt the technology. There are a lot of technologies scattered there, but you have to adopt the technology. You need a lot of innovation so that they can be custom built for our country. Because we know that Strata actually worked with some wastewater recovery system in Canary-Ganj area. But it was basically, we tried to adopt the German technology. It didn't work properly because we just wanted to copy their things. We have to use our local innovation so that you can use it efficiently. We can use it, we can custom build the technology so that it suits our environment, our conditions, and our requirement. Just maybe a few seconds. There are a lot of technologies there, energy efficiency technologies there. We need to disseminate the knowledge so that we can use it, and also we need the technical support system so that the industry feels very comfortable with that things. Because I have seen a lot of companies, they don't want to go for the wasted vapor absorption system and that sort of things. They have the feelings that, okay, if something goes wrong, then who is going to repair it, that sort of things. So we need that sort of in-house skill development program so that we can choose wisely, we can use efficiently. Just solar energy, we are in Bangladesh, we are very much involved with the solar PV system. But if we look at the energy forecasting by International Energy Agency, 50% of the solar energy is used in the solar thermal, 50% is the solar PV system. Because solar thermal system has a much higher heat absorption rate. But solar PV system, it is good because it directly gives you the electricity, but on many occasions, we may not, some of the industries may not need electricity. They may need heat. They may use the heat for the maybe a solar absorption system, solar cooling system, that sort of things. So we should form some network, form some guidance mechanism so that we get the information and we can use it efficiently and economically. Thank you very much.
Thank you very much. I'm told you get busy, listening to people. So do you think we should give a break for 5 minutes and then come back? Is that the consensus? Can I see some hands to see? Okay. So let's take a break for 5 minutes and then we'll resume. We have 5 more panel discussion on the renewable energy and digital technology, and then we'll have a session for Q&A. Thank you very much.